Let's talk about composite functions. In this video, we're going to go through a bunch of examples here and try to make some sense of this. It's kind of an interesting little skill. This word composite means like a combination of things. You know, in other words, like if you have like a composite baseball bat, it might be made of aluminum and graphite instead of just one or the other, or so the word composite just means like something that's made up of various other things. And it's kind of the same thing in this skill, in this mathematical skill. When we compose functions, we're basically combining them with other functions. And there are a couple different rules here. Let's get into the notation first, and then we'll go through some examples. But what you're going to see when you compose functions and you do composite functions is this little circle. So that little circle, it kind of reads from left to right like f composed with g, of x. That's the same as writing f of g of x. And the same would be true if you were to have it written the other way. This would be g of f of x. So what you're looking at here is basically like the first function that I look at is the letter that's closest to x. That one is sort of nested inside of the one that's out here. And same thing for right here, right? F of x is sort of listed second. F is closest to x, so that's the one that's going to be sort of nested inside of g, which is listed first right here. So that's a little bit confusing in terms of notation, but I wanted to show you that just because you're going to see this circle, this use of the circle here, and when you see that, that's means to do some composite stuff. So let's do some examples. Number one, I'm giving you that the function f is negative 4a minus 5 and the function g is a to the third power plus 2, and I'm asking you to find this composite. So what I like to do is change that to f of g of a. I like to write it in that notation because that helps me see that what I need to do is I need to write my function f. I need to write f, but instead of using this a right here, what I need to do is use this entire function g, and I need to put it inside of a. So in other words, a to the third plus 2, and then I finish up with the rest of the f function. So I just kind of did like a little fancy little substitution there. I substituted g, the function g, inside of the function f, and then I simplify. So negative 4a to the third minus 8 minus 5. This is f of g of a. And I just combine like terms, negative 13, and I'm done. So that's what that is equal to. Again, if you want to use the other notation, it's good to know both. But that's the final answer. That's all you would do. It's kind of rewriting sort of a new function rule, the composite of f and g, when g is sort of nested inside of f. Number two, I'm going to rewrite g of f of a, and now I'm going to write my g function, but instead of writing the a, I'm going to leave it blank. So check this out. Here's the a, and I'm leaving it blank, and I'm going to replace it with the f function. Alright, so I wrote the general g function, and then I'm just doing a simple substitution. The variable gets substituted with the entire function f, and we simplify. So this is 2, and then we have binomial cube. Let's expand that. If you had to expand it, you would just simply FOIL this. I'll do 2 at a time. I forget my cubing rule, so I'm going to just FOIL these two first, which is a squared minus 8a plus 16. I'm going to multiply that by this binomial. So I'll get some more space. The 2's out there in the beginning. So now I need to take this thing, I need to take this and sort of distribute it back into all three. So I go a squared times a minus 4, which is a to the third minus 4a squared. The middle one gets distributed, minus 8a squared plus 32a. And then this one gets distributed into the binomial as well, plus 16a minus, what is that, 64, plus 1. So let's clean that up in the middle here before we distribute the 2. A to the third minus 12a squared plus 48a minus 64 plus 1. And let's see, I think that's simplified all the way. Minus 12, yeah, looks good. So now let's take that 2 and we'll distribute it into everything on the inside. And this is all algebra, really. 48 times 2 is 96 minus 128 plus 1. Negative 128 plus 1 is negative 127. So there you go. That is the result of taking g of f of a, which again is the same as writing it this way. There you go. Okay, cool. Let's try this one. H of g of n. So I'm going to write my h function instead of using my n variable. I'm going to leave a space. I'm going to leave a space for my g function to go right inside there. So g nests inside h. So I get negative 8n squared minus 4n minus 4. And if you wanted to, factor out the 4's or whatever you can, but I'm going to leave it just like that. That's a good answer. A couple more here. Getting some actual numbers now. This is a f of g of negative 7 composite. So what I want to do first is find g of negative 7. Do that first. So let's do, we're kind of working from the inside out now. G of negative 7. So I'm going to plug in negative 7 into g and see what I get. So I get negative 7 squared plus 3 times negative 7. 49 minus 21, which is 28. So now I need to find f of 28. See how that works right there? G of negative 7 and 28 are identical to each other, so I just literally just switch them out. F of 28 is equal to negative 3 times 28 plus 2. So let's see, 28 times 3, that's 60 plus another 24, that is negative 84 plus 2, which is negative 82. So my final answer, f of g of negative 7, is negative 82. Number 5. Number 5, we want to find f of g of 2. So again, I'm going to find g of 2 first, and we'll work from the inside out. G of 2 is negative. I'm going to replace the x's with 2. What I'm doing here is I'm finding g of positive 2 first in that function, and I get negative 8 plus 6, which is negative 2. So g of 2 is negative 2. So now I need to find f of negative 2. So f is 2 times x minus 3. So it's negative 7. So that's my final answer. That's f of g of 2. Alright, let's go a little faster here. F of g of negative 2. might be a good time to pause and try this one on your own. I'm going to find g of -2 first, so I get -2 squared minus 2, so that's -4 minus 2, which is -6. So I need to find f of -6. f of -6, 3 times -6 minus 2, so that's let's see, 18 minus 2 is -20. I bet you're getting the hang of this by now. Number 7, last one. Now we're going to actually do something a little bit different here. This is f of g of n plus 1. So this is, composing with not a number but an expression. So we're not going to end up with a number at the end. We're going to end up with an expression, but we're going to work from the inside out. So I'm going to find g of n plus 1 first. So we just evaluate this function for n plus 1. So it's 4 times quantity n plus 1 minus 2. So that's 4n plus 2. So now I find the function, the f value, when the f value of 4n plus 2. So now I'm going to go up here, and every time I see an n, I'm going to replace it with 4n plus 2. And simplify. So I get, let's see, I have to FOIL this, so 16n squared plus 16n plus 4 minus 4n minus 2. Distributed that negative into both here. And let's see, 16n minus 4n is 12n, 4 minus 2 is 2, and I'm finished. So that's what we get when we compose f of g of n plus 1. Now you can also do like a triple composition if you want. If you have like f of x equals x plus 1 and g of x equals 3x minus 4, and then maybe h of x equals x squared. You can do something like f of g of you can do like f of g of h. If you compose all those together, you would do that in that order. So f of g of h of x, and you just kind of like do a triple sort of nesting here. You start with h of x, and you put h of x inside g of x, and you put that result inside f of x. So I'll do this really quickly here. So I'm going to write g. I'm going to do this part first. So g of x would be 3 times, instead of x, I'm going to write x squared because that's h minus 4, so 3x squared minus 4. And then I'm going to find I'm going to evaluate f for that thing. So f is x plus 1, but I don't want to write x, I want to write 3x squared minus 4 plus 1. So my final answer would be 3x squared minus 3. So it's kind of an interesting thing. You can also, instead of evaluating just sort of generally, you can evaluate for a specific function value, like I don't know, 7 or something. So you would just work from the inside out. Find h of 7 first. H of 7 is 49, and then find g of 49. 3 times 49 minus 4, that's 120 plus 120 plus 27 is 147 minus 4 is 143. And then I'm going to find f of 143. F of 143 is 143 plus 1. So that's how that would work from the inside out. Kind of an interesting little activity there, but that concludes the video on composites. In the next video, I'm going to do some combinations of stuff that looks very similar to this. It's not really composing functions, but adding two functions together, or subtracting, or multiplying, or dividing. So look forward to that, but make sure you subscribe, and thanks for watching. Bye.